The given question states that a body of weight 500 Newton is pulled up on a rough inclined plane whose inclination to horizontal is 30 degrees by a force of 360 newtons acting parallel to the plane. Find the coefficient of friction. So let me just draw the inclined plane. So here is the inclined plane. Let's say this angle is 30 degrees. On this inclined plane, a block is resting and the weight of the block is 500 newtons. Now, this block is being pulled by a force of 360 newtons. So, if it is being pulled by the force of 360 Newton, what would be the friction that is going to act? So let's say P is equal to 360 Newtons and we are required to calculate what is mu value. So now here, let's identify the forces acting on a body. So very first force, that would be the self weight or weight of the body, which is going to act vertically down, the weight of the body, and due to the contact between the block and the plane, there will be a normal reaction. The normal reaction will be perpendicular to the inclined plane. Let's call this normal reaction as Rn. And now the body is being pulled up the inclined plane and the description of surface is given. So there will be one more force that would be opposing the motion, and that is friction force. The friction force will be acting opposite to the applied force P. Let's call this as F. So here the friction force, we can write it as mu times of Rn. The weight of the block can be resolved along the inclined plane and normal to the inclined plane. So let me just realign the forces. So this would be weight of the block, which is acting along the inclined plane and normal to the inclined plane. Now the component normal to the inclined plane is going to make an angle of 30 degrees with the vertical. So this rule we have already discussed, that is, if a line makes an angle theta with the horizontal, the normal of that line will make the same angle with the vertical. So this rule we have discussed in the statics part of the subject. And here if it is 30, this would be W cos 30 and other component would be W sin 30. So now here if we take the equilibrium of forces in the y direction, that is Rn minus W cos 30 equal to 0. So Rn will be equal to W cos 30. Same way we need to take equilibrium of forces in the x direction, that is sigma fx equal to 0. That is P is the applied force, against that friction is going to act, and the component of weight, that is W sin 30. This is equal to 0. So P here is 360 and F is mu times of Rn, and Rn will be equal to 500 cos 30. So this is minus mu times of 500 cos 30 minus 500 sin 30 it would be. This is equal to 0. So upon solving, we would be getting mu as 360 minus 500 sine 30, that is 250. 360 minus 250 divided by 500 cos 30. So upon solving this, we would be getting the answer as 0.254 would be the coefficient of friction.